Good morning, algebra students, or afternoon, whenever it might be. It's morning for me. Today we're going to be starting a new section on arithmetic sequences. So I'm going to go ahead and share my screen and start the presentation. And you'll need a piece of paper. The first slide is the warm-up. So if you haven't already done so, grab some paper, pause the video, and work on the warm-up. Okay, welcome back. Hopefully you had a chance to try that. You are putting 2 in for x and evaluating this expression. And then you'll put in 3 and evaluate, and then 4. All right, let's go ahead and look at today's topic, which is arithmetic sequences. And sequences are just like a pattern. So let's look at this first sequence. It says mental math, describe each number pattern, then find the next 2 numbers in the pattern. I'm also going to grab a pen here. So if I look, I'm trying to see what's happening as I go from term to term to term here. It looks like, well, they're getting bigger. And how much are they getting bigger by? Well, let's see, from 21 to 27, that's 6. That's also 6 here and 6 here. So my number pattern for this first one would be, on part A, is we are adding 6. And to find the next 3 terms, or excuse me, next 2 terms, I'm going to add 6 2 times. So 27 plus 6 would be 33, and 33 plus 6 would be 39. All right, this one, this time it's alternating positive, negative. We're not adding the same number. Let's see, it looks like if I multiply 8, I can get 16. So let's see, it looks like maybe I'm multiplying by -2. And yes, that looks like the pattern. So I'm going to put multiply by -2. That's a little awkward looking. You could write it in words. And so the next 2 terms, -16 times -2 would be a positive 32. And 32 times -2 would be a -64. Let's look at our last one. This time they're definitely getting smaller. From here to here, I definitely subtracted 4. Is that the same thing here? Yeah. So this time our pattern is subtract 4. And if I subtract 4 from 7, I'm going to be at -11. And if I subtract 4 from 11, I'm going to be at -15. All right, you have some vocabulary to write down on page 123 in your journal. So pause the video and write down these definitions. All right, there are 2 note sections on page 123 in your journal. So please write this example in the first note section on page 123. There's not a whole lot of room, so please try to fill this in. So pause the video and copy these down in the note section. All right, welcome back. Let's take a look at these. Find each common difference. This is like our number pattern process. Again, we're trying to see what are we doing to go from term to term here. And it looks like we are adding 7 every time. And so our common difference, which we call D, is 7. All right, let's look at this one. This time they're getting smaller. Looks like we're going down by 2 every time. And so our common difference is a -2. Last one, this time we're going up by a decimal value. Looks like this increased by 0.5. And again here, same thing. So this time our common difference would be 0.5. Right, let's continue. It says you can find the value of any term in an arithmetic sequence by using the following rule, and this is in your journal. So an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Don't be intimidated by this n or nth term. It's just what is the term you're trying to find. So if you were trying to find the 10th term, this would be a sub 10. If this were the 50th term, a sub 50, the 11th term, a sub 11. So don't worry about that. That's just the term you're trying to find. This number here is always the first number in your sequence. This is the term number you're on. For example, if you were trying to find the 12th, this would be a 12. And your common difference is that amount that you're adding or subtracting each time to get the next term. All right, so please add this example to the note section at the bottom of page 123. And it says find the first, 5th, and 10th terms of each arithmetic sequence. And we only have one, so we're trying to find 1st, 5th, and 10th. So we can find the first, just let me grab my pen here, choose a different color. We can find the first term just from the pattern itself. Remember, this term here is always the first term. So our first term is -5. And then if we want to find the fifth term, we're going to write a sub 5, and I just say sub for subscript, equals -5 plus, and I'm replacing n with 5 because we're doing the fifth term, times -3. So that -3 is our common difference. So we simplify this. We get -5 plus 5 minus 1 is 4 times -3. So we're doing the common difference 4 times. So we have -5, and 4 times -3 is a -12. And -5 plus -12 is -17. So the fifth term in this sequence would be -17. Let's look at the 10th term. The 10th term would be the first term plus 10 minus 1 this time, times the common difference of -3. So we get -5 plus 9 times -3, because we've done the pattern 9 times. And we have -5 plus 9 times -3 is -27. And so our 10th term would be -32. And students a lot of times will ask, well, can't you just look at the pattern and keep going? And yes, you can. Instead of using the rule, you could just write out all the terms, which is fine if you only have 10, but if you're looking for the 25th or the 50th, that can get pretty tedious writing those all out. So the pattern is helpful. All right, let's jump to some extra practice on page 124. It says write the next 3 terms. So in order to do that, we have to look at what is our common difference. And what are we going up by here? It looks like we're going up by 7 each time. So our next 3 terms would be 29. And if we add 7 to that, we get 36. And if we add 7 to that, we get 43. All right, this time it looks like we are going up by 12 here. Yeah, and that looks true to all of these. So if we add 12 to 38, we get 50. Add 12 again, and we're at 62. Add 12 again, and we're at 74. Okay, this time we're graphing. So to graph, these are the output values, these numbers they give you. Your input value is the term you're on. So this is my first term, second, third, and fourth, and so on. And they put ... but we're just going to graph these 4 terms. So I'm going to put in my axes here. All right, so I'm just doing 1, 2, 3, and 4. And this side 1, 2, 3, 4, 5, 6, 7. So my first term is 1, so I graph the point 1, 1. My second term is 3, so I go to 2, 3. Third term is 5. And my fourth term is 7. Now, one thing that's interesting to note on this is that your common difference is your slope here. I'm going to change color for a second. So if I notice, my slope here is, I have a rise of 2 and a run of 1, rise of 2, run of 1. So this slope here, if you notice, your slope is 2 over 1, or just 2. And that is also the common difference between these terms. So that will help you double check you've done it correctly. I'm going to switch back to blue again. This time, our sequence is decreasing. But it shouldn't matter. Again, this is our first term, second term, third term, and fourth term. So I'm going to do 1, 2, 3, 4 again. And you could keep going. You could put more points on the graph. We got to get up to at least 9. All right, so this time we have the 0.19 as our first term in the sequence. Second point is 6. Third, we're at 3, 3. Fourth, we are at 0, right? After that, we're going to be going below the axis, but these were all above the axis. So again, this time, if I look at what my slope is this time it looks like my slope is going down 3 and over 1. And again, that's a negative. If you look, that is your pattern here. We are subtracting 3 between each term. All right, let's continue. It says determine whether the graph represents an arithmetic sequence. Explain. So let's take a look at this one using that same idea we had in the last slide where we're looking at what do these go up by. So if I look here, we're going up by 1 and over by 1. Here we're going up by 3 and over 1. Here we're going up, let's say 1, 2, 3, 4, 5 and over 1. So our slope changes every time. It's not consistent. You can see this as a gain of 1, a gain of 3, and so forth. So this one would not be. It's not arithmetic. And our reason is the common difference isn't the same. Or you could say there is no common difference. I think I'll word it that way. That makes more sense. All right, let's look at this one. If I look, my x values are going up by 1 every time, or excuse me, my y values are going up by 10, and my x is 1, 10, 1, 10, 1. So these increase by 10 every time. So this time I would say it's arithmetic. And we can see in this pattern that our common difference is 10. All right, on these, this is number 16 in your journal, more extra practice. It says, write an equation for the nth term of the sequence, then find a sub 10. So when you're writing the nth term pattern, we just start with a sub n. Then we put our first term, which in this case is negative 5.4, plus, and our rule would be n minus 1 times, and then we need to find our common difference. So it looks like each time it's going down by 1.2 on each of these. So our common difference would be a negative 1.2. To find the 10th term then, a sub 10 would be equal to negative 5.4 plus, and since it's the 10th term, we're replacing n with 10. And I'm going to keep simplifying. We have negative 5.4 plus 9 times negative 1.2. So that would give us negative 5.4 plus, and this is a negative 10.8. And negative 5.4 plus negative 10.8 is a negative 16.2. So that's our 10th term. All right, I'm going to switch colors so I don't run into the next problem. Excuse me. All right, so this time looks like common difference is 4. So our pattern is a sub n equals 6, right? And I'm getting that from the first term here, plus n minus 1 times a common difference of 4 this time. Our 10th term, therefore, is going to be 6 plus 10 minus 1 times 4. Our 10th term is 6. Oh, that's a crazy 6. 6 plus 9 times 4. And I'm going to move this over here. That's a 9, by the way. So we have a sub 10 equals 6 plus 9 times 4 is 36. So our 10th term is 6 plus 36, which is 42. Okay, one more to try in this set of problems. Okay, this time our pattern looks like we are climbing up this time. All right, these numbers are getting bigger. They're getting bigger by 2. So our 10th term, or excuse me, our nth term, let's start with that. A sub n equals our first term, which is negative 11, plus n minus 1 times a common difference of 2 this time. So we have negative 11. Oh, excuse me, this is our 10th now. A sub 10 equals negative 11 plus 10 minus 1 times 2, which is negative 11, plus 9 times 2, which would be negative 11 plus 18, which gives us that our 10th term is negative 11 plus 18 is 7. All right, this time we have a word problem. It says in an auditorium, the first row of seats has 30 seats. Each row behind the first row has 4 more seats than the row in front of it. How many seats are in the 25th row? So when you encounter a problem like this, you kind of need to decipher what they are telling you in an arithmetic sequence. So let's look here. We have this, the first row of seats has 30. That's our first term, the 30. This part here where it says each row has 4 more seats, that's our common difference is 4. And it's asking us to find the 25th. It's asking us to find a sub 25. All right, so using our pattern, we'd have a sub 25 is equal to a sub 1, which is 30, plus n minus 1, which in this case is going to be 25 minus 1, times the common difference, which is 4. There's 4 more seats in each row. So we have 30 plus 24 times 4. And so we have 30 plus 24 times 4 is 96. So in the 25th row, we have 30 plus 96, which is 126 seats. Our last slide, I believe, is the assignment. Yeah, links to these pages are in Schoology. I did change it a little bit, so make sure that you are only going up to problem number 43. Make sure when you do the assignment that you are doing all of them. Also, if you could please write this on your paper somewhere. Some of you are just turning in papers with problems on it, and it's really hard for me to know what assignment it is you're turning in. All right, that's it for today. Good luck, and email me if you have any questions.